Greetings, M Squared here. We're going to solve some equations using common logs. They start off a little bit simple, but they get kind of complicated, and we're really going to have to slow down and make sure that we're getting everything in the correct place, because this can get kind of tricky. So before, when you had equations like this, you just said, oh, 4 to what power equals 40? But you can't do that here, because 4 to some power, like an integer, doesn't work. So we know it's going to be a decimal. So we use common logs to help us with that. So just like you can add something to both sides of an equation or multiply both sides of an equation by something, you can take the log of both sides of an equation. So, oops, I forgot to take the log of that side. So that's the first thing we do. We take the log of both sides. Then we use our rules. First of all, this little exponent, we know if we have it in the logarithmic form that it goes down in front. So I have 2a of log 4 equals the log of 40. My goal is to get a alone. Since the 2 and the log 4 are both being multiplied by the a, I can divide by 2 log 4. Some people think that's a little strange, but if they're both being multiplied, I can divide by both of them, because those 2's cancel out and these log 4's cancel out, and I'm left with the a. So a is going to be equal to, get your handy dandy calculator out, and we're going to say the log of 40 divided by 2 times the log of 4. And we get 1.3305. And you could always check that. We could multiply it by 2 and take 4 to that power. So 4 to that power should be 40. And what do you know it is? Okay, so now we're going to do this one. So again, we're going to take the log of both sides. So we get the log of 3 to the b squared equals the log of 64. This exponent comes down in front, so we get b squared log 3 equals the log of 64. And so we're going to divide both sides by the log of 3. And then we're going to end up taking the square root, because b squared equals this. So let's figure out what that is. So we're going to take the log of 64 and divide it by the log of 3. And we get 3.7855. And then b is going to be equal to the square root of that. So we just take the square root of our answer, and we get 1.9456. And you could check that if you want. I won't take the time to do it right now, but it's a good idea to do that. So now we're going to get into a little bit more complicated ones, because there's a binomial up here as the exponent. So again, take the log of both sides. Always check, does 5 to some power equal 30? It doesn't, but when you have that chapter test, you're going to have to check which one to do, if you're just going to get it into the same base, or if you're going to have to take the log of both sides. So I take the log of 5 to the m squared plus 1, and I set that equal to the log of 30. Then I bring my exponent down in front. So I get m squared plus 1 times the log of 5 equals the log of 30. I'm going to distribute now, because this is a binomial times a monomial. Remember, this is the log of 5, it's not just 5. So I get m squared log 5 plus 1 times the log of 5, which is just log 5, equals the log of 30. Now I need to get m squared alone. Well, this is being added to this m squared term, so I have to minus the log of 5 from both sides. So let's do that. M squared log 5 equals the log of 30 minus the log of 5. You want to be careful that you don't just say 30 minus 5. You have to take the log of 30 and minus the log of 5. And we get 0.778112. Now I'm going to divide by whatever's preventing the m squared from being alone, so I'm going to divide by the log of 5 on both sides. And I'm not going to clear out my calculator, I'm just going to say, because this answer is already in there and it's not rounded, I want to keep it that way. So I'm just going to say divide by the log of 5. So now I have m squared equals 1.1133, and this is when I take the square root. So square root of my answer, and I get m equals 1.0551. Okay, on to the next one, which is a little more complicated because we have binomial exponents on both sides. So I'm going to, again, take the log of both sides. I'm going to skip that step. I'm just going to put it down in front. So I'm going to say n minus 3 in parentheses times the log of 9 equals n plus 3 times the log of 2. And now I'll use my distributive property. So I'm going to get n log 9 minus 3 log 9 equals n log 2 plus 3 log 2. So now I need to get all the n's on one side in order to solve for n, and then I need to get the terms that do not have n's in them on the other side. So I'm going to be minusing n log 2 from both sides, and I'm going to be adding 3 log 9 to both sides. So those cancel, and I get n log 9 minus n log 2 from these guys, and that's going to be equal to 3 log 2 plus 3 log 9. Then I'm going to take out an n, or just factor out an n. So I get n times the log of 9 minus the log of 2 equals 3 log 2 plus 3 log 9. I'm just going to get n alone, and then we'll kind of worry about the rest, simplifying those. So I end up dividing this side by whatever's being multiplied by n, which is a binomial. So it gets that's what gets kind of messy. And I like to leave everything in log form until the very end. I don't like to round and then round and then round. It kind of messes up your answer a little bit. It doesn't make it as accurate. So this is my answer. So I'm going to figure out what this is and put that in the top. So I'm going to say 3 log 2 plus 3 log 9. And that was in the top, 3 log 2 plus 3 log 9. And it is 3, 7, 6, 5, 8, 1, 7, 5. And I like to go beyond so that when I round later, I can have the rounded answer that's more accurate. So now I'm going to take and do the bottom. The denominator is the log of 9 minus the log of 2. I get 0.6532. 125 anyway. Now I'm going to divide these two. So I get 3.7658175 divided by 0.6532.125. So n is equal to 5.7651. And if I put that up there, if you wanted to check it, this one says to minus 3 from it. So n minus 3 is equal to 2.7651. And this one says to add 3 to it. So n plus 3 is 8.7651. So I'm going to take 9 to this power. And that is approximately equal to 435. Then I'm going to take 2 to this power. 8.7651. It's just nice to know if you're right or not. And that's approximately equal to 435. So then we know we're right. And checking, especially on a test or quiz, is important because, you know, it doesn't take too long, and then you can know if that answer is correct. And if you made a mistake, go back and find it. And this is M Squared, signing out.